Hello, my name is Victor Stepanov. I'm a master's student in mechanical engineering at Northwestern University. For my capstone project, I developed a robotic endoscope controller, which would help surgeons to perform procedures such as endoscopic subdural mucosa dissection, as well as eliminate the hand preference and hand size, and help just overall manipulation. The short video will guide you through my developmental process.
Neutral should be straight, essentially.
Straight.
Yeah, so if these are both unlocked, that's unlock.
Okay.
Then this kind of wants to be relatively straight. You might have a little curve in it, but
Okay.
that's neutral. And then from there you can move it around. But see, this the first, if we can get control of this and these buttons and be able to do the rotate and in and out. This is for taking little biopsies. I don't know if you can see the tip of this thing. I'll put it down here maybe. And then when I open with my thumb here, the little jaws open up. And then I'd stick it on the polyp or whatever I want to biopsy, tell the nurse to close, and she'd close. So at this point, I'm in a position where I want my scope to be. I have to let go with my right hand, hope it doesn't lose it. And then I can advance and control this over here, and the nurse is holding this.
Whoa.
So there's a lot of hands going on.
So at least four?
Yeah. So if this could, if this thing could plug into something, and then the ESD, the endoscopic submucosal dissection I was talking about, the device that comes out here it's called a needle knife. So it has an injection needle, so you can blow up the mucosa essentially and lift it off of the bowel below.
Okay.
And then you can also cauterize. So usually you just put it out at one level, and then you don't adjust it anymore.
Okay.
And you do your thing, like pretending this is a needle or whatever. I would inject the mucosa, lift it up, and then go back and forth and try to.
This is the CAD assembly of the version 1 of the prototype. The entire assembly will be mounted to the wheeled cart. The control head with control knobs pointing into the device will be mounted in this part of the device, fastened via these brackets. The scope itself will be routed pointing down and making a nice 90-degree sweep, ending up parallel with the bed of the patient. The control knobs are going to be rotated by the stepper motor driving this big gear with a 4:1 ratio for now. Inside of this gear there will be an insert that conforms to the exact geometry of the angulation knob. Here's a small animation. The vacuum will be controlled by this linear actuator. Meanwhile, the air and water will be controlled by this linear actuator. Inside of the body, the tip will slide in and out, meaning translate, by 20 centimeters using this assembly here. It's essentially a linear actuator comprised of lead screw and linear guides. Meanwhile, the rotation of the tip will be achieved by this mechanized revolute joint. Here's a small animation of the tip will be sliding with the assembly in and out of the body. And this will control the rotation. Here's an example of the prototype development for the knob rotator. Here I was just trying to understand exactly what each button does. Here I drew it a little bit more from various different angles, and here I'm starting to consider how to control some of these motions. Here's another drawing with the dimensions I collected in the lab with the caliper. This I just needed to construct it because I really wanted to play with it, but I didn't have access to the actual equipment. Here's just some more drawings. Here I developed the ball bearings of how I'm going to actually rotate some of these gears. Some more of this. Here's just a first proof of concept ball bearings. Here are the 4 stages of the gears. Here's the more development of this concept. Here I eliminated 2 gears already because of the stepper motors. And then here you can see the ball bearings. This is a cutout for the angulation lock that's not going to be used. This is just the development of various iterations of the what I call bottom plate. And now this is the dial knob rotator assembly. And then here's the prototype, 3D printed. Currently I am writing the firmware to control all of the motors, actuators with the PS2 wireless controller. Originally I used an Xbox controller that I rewired, getting all of its raw signals, but it was just not reliable. And once I finish writing the firmware, then I will do the CAD redesign to be able to fit the device and hopefully be able to test it in the lab. Thank you for watching this video.